In the examples I've done so far, the purpose was to determine which of the three conditions is satisfied, and if one of them is satisfied, then the limit will be either Gumpel, Frechet, or Weibull. But what I have not discussed is how to choose the two constants, the an and the bn. So that's what I'm going to talk about in this video. How to choose the constants an and bn. So if condition 1 is satisfied, then an can be chosen as this, and bn can be chosen as this. Here gamma is the function. Remember when I talked about the first set of conditions for checking which of the three limits is attained, I talked about a function called gamma. So yeah, if the second condition is satisfied, then an is equal to this, and bn is equal to 0. And if condition 3 is satisfied, then an is equal to w of f minus the inverse function of f at this, and bn is equal to, sorry, I made a mistake. Let me use my ink to erase what I have written here. Sorry, bn is equal to w of f. Okay. So depending on which of the three conditions is satisfied, you choose an and bn correspondingly. Okay. So as I just mentioned, just to reiterate, f minus this denotes the inverse function of f. Okay. So now I'm going to do 3 examples, the same 3 examples I did in one of the previous videos. So I'll start with example 1. Example 1. So here you may recall this example. This is where f of x is equal to this, and we knew from the various examples we did previously that condition for this example, condition 1 holds with gamma t equal to 1. You may check this from a previous video that I did. Right, now to find an and bn, the first thing you must remember, okay, let's let me show you the previous slide. This is the previous slide. Okay. So since condition 1 holds, this is the formula for AN and this is the formula for BN, right? So what this implies is that AN now, since the gamma function is identically equal to 1, this must be, it doesn't matter what the argument is, it is always equal to 1. So hence this must be equal to 1. Now to find Bn, we need to find the inverse function of f. So the way to do that is to set f of x equal to this, so, and solve for x. So whatever you get out of this equation will be the inverse function of f at 1 minus 1 divided by n. Taking the log, you get so x is equal to log of n. So this will mean that Bn is equal to log of n. Alright, so we have found An and Bn. Alright, so hence by the ETT, by the extremal types theorem, yeah, the f at An times x, because since An is 1, is simply x, plus Bn, which is log of n to the power n, must approach the Gumpel limit, right, as n goes to infinity. Okay. Right, so this is example 1. The next example is example 2. Alright, this is the same example 2 I did in at least 2 of the previous videos. So I'm going to choose fx as 1 minus 1 over x, and we know from the previous videos that for this example condition 2 holds. Right. So to find the An and Bn, we need to, if you look over here, guys, An is given by this formula and Bn is 0. So we need to find only the inverse function of f at 1 minus 1 divided by n. So to do that, as I said before, you just set fx equals to this and solve for x in terms of n. So An is simply equal to n, and Bn from the formula sheet that we know that Bn is 0. So we have found An and Bn, and hence by by the extremal types theorem, ETT, f at an(x), which is nx plus bn, which is 0, power n, approaches the Frechet limit, and the limit, you may recall, has alpha equal to 1, right? So right, because you should look at the previous videos where I did example 2, the same example 2. You may recall that condition 2 holds with alpha equal to 1. So that's why you have the power minus 1. Right. And finally, example 3. For this example, the CDF f of x equal to x between 0 and 1. And if you look at the previous videos, you will see that for this example, condition 3 holds with alpha equal to 1. Alright, so if you go back to the formula sheet, the an is given by this formula and bn is given by this formula. So once again, we need to figure out what the inverse function of f is at 1 minus 1 over n. So to do that, you set the CDF equal to 1 minus 1 over n, and then solve for x. So x is equal to this, therefore okay. So hence your an, remember an is w of f, which is 1, minus the inverse function at this, which is 1 minus 1 over n, and hence, because the two 1's cancel, you get 1 over n, and your bn is equal to w of f, which is 1. So hence, by the extremal types theorem, f at an(x), which is x by n, plus bn, which is 1 to the power n, approaches the Weibull limit with alpha equal to 1. So E of x if x is less than 0, and 1 if x is greater than or equal to 0, as n goes to infinity.